Imagine the moment when humanity finally surpasses the ultimate limits of Earth and transforms space into a royal highway of exploration. You are inside an interplanetary exploration spacecraft, surrounded by silent technology and holographic screens that show orbital trajectories dancing like lines of light in the void. Outside, Earth still dominates the view, slowly rotating, blue, white, and alive, like a jewel suspended in absolute darkness. At that instant, a feeling difficult to explain arises, a mixture of pride, fragility, and profound admiration, because for the first time you realize that all of human history, wars, discoveries, entire civilizations happened on that small, luminous point. The solar system, which before seemed like just an organized set of planets in textbooks, begins to reveal its true nature. A dynamic system, violent in its origin and incredibly complex in its evolution. Billions of years ago, before Earth existed, before the sun shone as it does today, it all began with a colossal cloud of interstellar gas and dust. This cloud, formed from the remnants of ancient stars that exploded as supernovas, slowly began to collapse under its own gravity. As it spun faster and faster, the material at its center became so compressed that it initiated nuclear reactions, giving rise to the sun. Around it, the remaining material formed a gigantic disk of hot dust and turbulent gas. Within this disk, microscopic particles began to collide, merge, and slowly grow over millions of years, forming rocks, then space mountains, then entire worlds. Each planet was born from violent collisions, chaotic mergers, and constant changes, creating a system where each object carries scars from the cosmic past. As your spacecraft begins to move away from Earth, the Moon slowly emerges, revealing its surface marked by billions of years of impacts. Observing the lunar craters up close, it's impossible not to think about the fragility of life on Earth. The Moon acts as a historical archive of the early solar system, preserving scars that Earth erased through erosion, tectonics, and atmosphere. Some scientists believe that the Moon arose from a gigantic collision between the early Earth and a Mars-sized object, an event so violent that it vaporized entire rocks and scattered material throughout space, which then reorganized to form our natural satellite. Without the Moon, Earth could be a completely different world, with unstable weather and chaotic rotations. The spacecraft then accelerates towards Mercury, the closest planet to the Sun, where heat and cold coexist brutally. During the day, temperatures can exceed 400 degrees Celsius, while at night they plummet to freezing temperatures. Mercury is a world of extremes, a reminder that not all planets have thermal balance or atmospheric protection. Its surface looks like an enlarged version of the Moon, but with even older scars, marking the first chapters of planetary formation. Further on, Venus appears, shining like a star in the dark sky. From a distance, it seems beautiful and calm, but upon closer inspection, the reality is terrifying. The thick atmosphere, composed mainly of carbon dioxide, creates such an intense greenhouse effect that it transforms the planet into a hell of constant heat. The atmospheric pressure is crushing, equivalent to being almost a kilometer deep in Earth's oceans. In the distant past, Venus may have been much more like Earth, perhaps even with liquid oceans. If this is true, then Venus is a frightening example of how planets can completely change over time. Then comes Mars, the planet that perhaps most evokes emotion in humanity. The red surface reveals endless deserts, gigantic canyons, and colossal mountains like Olympus Mons, the largest known volcano in the solar system. Mars once had rivers, lakes, and perhaps oceans. Geological evidence shows that billions of years ago, Mars was warmer and wetter.
As it lost its atmosphere and magnetic field, the water disappeared and the planet transformed into a frozen desert. Still, there is the possibility of liquid water underground, and perhaps even microorganisms surviving in protected pockets beneath the surface. Mars represents not only the past of habitable planets, but perhaps the future of human expansion. As the spacecraft continues, the asteroid belt emerges, a region filled with fragments that never managed to form a complete planet due to Jupiter's powerful gravity. These objects are time capsules from the early solar system. Some contain frozen water and complex organic molecules, raising one of the most profound questions in modern science. Did the ingredients of life come from space? As you observe these ancient rocks slowly floating in the void, it becomes clear that the solar system is not just a collection of planets, but a living history of birth, destruction, and continuous transformation. Each world is a chapter, each moon a natural experiment, each asteroid a piece of the past frozen in time. And as the spacecraft approaches the edge of the rocky planets and begins to feel the gravitational pull of the gas giants, an inevitable feeling arises. The journey is only just beginning.
As the spacecraft leaves the asteroid belt behind, the sensation changes completely. Space seems deeper, quieter, and colder. The sun no longer dominates the sky as before, and its light transforms into an extremely bright but distant star. It is at this moment that the first of the giants appears on the horizon, Jupiter. Initially, it appears as a striped sphere, but as the spacecraft approaches, it becomes impossible to ignore the absurd scale of this world. Jupiter is not just a planet, it is almost a miniature solar system. Its gravitational field is so powerful that it controls dozens of moons and influences objects millions of kilometers away. The Great Red Spot rotates slowly, a storm larger than Earth itself, active for centuries, perhaps millennia. Within Jupiter's atmosphere, supersonic winds circulate in gigantic bands, creating patterns that look like living works of art, sculpted by the physics of chaos. While sensors analyze the atmosphere, scientific discoveries begin to appear on the monitors. Jupiter is composed primarily of hydrogen and helium, but inside, the pressure is so extreme that hydrogen can behave like liquid metal, conducting electricity and creating one of the most powerful magnetic fields in the entire solar system. This magnetic field generates intense radiation, capable of destroying electronics and posing a mortal danger to any unprotected human being. Even so, its moons represent fascinating worlds. Europa, for example, hides a global ocean beneath an icy crust. Some scientists believe that this ocean may contain more water than all of Earth's oceans combined. If geothermal heat exists at the bottom of this ocean, microbial life could exist there, isolated from the rest of the universe. Continuing the journey, the spacecraft enters the region of Saturn, and the scenery changes again, but this time to something almost surreal. Saturn emerges as a cosmic artwork surrounded by gigantic rings composed of trillions of fragments of ice and rock. These rings reflect sunlight and create a visual spectacle impossible to reproduce in any terrestrial environment. Each particle in the rings follows precise orbits, forming divisions and patterns that reveal the gravitational influence of nearby moons. The spacecraft slowly traverses an outer region of the rings, showing that despite their solid appearance from a distance, they are incredibly delicate and spaced apart. Among Saturn's moons, Titan immediately draws attention. It possesses a dense atmosphere, rich with nitrogen and complex organic compounds. On its surface, there are lakes and seas, but not of water, rather of liquid methane and ethane. Titan may represent an alternative version of how the chemistry of life could evolve under conditions completely different from those on Earth.
Some scientists believe that complex organic molecules are constantly being produced in its atmosphere and falling to the surface as a kind of chemical rain.
Further on, the spacecraft reaches Uranus, a planet that defies expectations. It rotates almost on its side, as if it had been knocked over during the formation of the solar system. This extreme tilt creates seasons that last for decades. Uranus is an ice giant composed of water, ammonia, and methane frozen in exotic states. Inside, it is believed that there is enough pressure to form diamond rain, solid crystals falling slowly through oceans of super-dense fluids. Uranus's magnetic field is strange, misaligned, and irregular, suggesting that the planet's interior is far more complex than we imagine. Soon after, Neptune appears, a deep blue world dominated by winds that can exceed 2,000 kilometers per hour. Despite being extremely distant from the Sun, Neptune is energetically active. Giant storms appear and disappear over the years, and its dynamic atmosphere defies scientific models. Its moon, Triton, is another fascinating mystery, possessing geysers that release material into space, suggesting internal geological activity even at extremely low temperatures. As the spacecraft travels beyond Neptune, the solar system slowly begins to disappear. The Kuiper Belt emerges, a region filled with frozen worlds and dwarf planets, including Pluto. These objects are relics of planetary formation, preserving information about how it all began. Further still lies the Oort cloud, a gigantic sphere of icy objects that marks the Sun's gravitational boundary. At this point in the journey, the Sun is just an ordinary star in the sky. A profound and almost philosophical feeling arises. The solar system, which seemed gigantic when viewed from Earth, now appears as just a small cosmic archipelago lost in an infinite ocean of stars. Each planet visited tells a story about possibilities: infernal worlds, subterranean oceans, complex chemical atmospheres, eternal storms, and alien landscapes that defy human imagination. And perhaps the greatest discovery of this journey is not about planets, moons, or rings, but about humanity itself. We are a species born on a small blue world, but with the capacity to understand entire cosmic systems. The journey through the solar system is, in fact, a journey to understand our own origin and our possible destiny among the stars. As the spacecraft slows down and prepares to return, a final view appears through the window: the distant Sun, surrounded by invisible points where worlds orbit that for billions of years have silently followed their paths. And there's an inevitable feeling that this is only the beginning, because beyond the solar system, there are billions of other systems, billions of other planets, and perhaps billions of other stories waiting to be discovered.